So good morning, everyone. So today we are just going to go through some more numericals on the topic what we had done last week or during this week. Sorry, not last week. That is photoelectricity and de Broglie. And before I do so, I think there's something about projection of area. We have done it 2 times. If suppose that there's an area vector A, so there's an area which is a vector is A, and area is a vector. Which direction we take the vector as perpendicular to that area. If that area vector makes an angle theta with the z-axis, then it's projection in xy plane. So angle is with z-axis, so projection on a plane perpendicular to z-axis is equal to a cos theta. That's the projection, and that is something I think somehow we can understand and keep this in mind. So suppose this is like x, y, and z axis, and see if the plane initially, if the plane was here, if the plane in xy plane, if the this plane makes an angle 0 with the z-axis, and if I start rotating, if this angle is theta here, so this shaded area makes an angle. If I draw this vector here, this area vector will be like this, perpendicular to the plane, and it will make an angle theta with the vertical, with z-axis. This area, if I take, what is its projection on xy plane? Since it makes an angle theta with z-axis, its projection will be its gross area A into cos theta. And this is something I have done once or twice. If those who are little not comfortable, just go through that again, and that becomes simple. So last week, a day before yesterday, we were at this question. Suppose there's a source of light. There's a source of light here, and which is okay, and it has a power of W. And this W is the power. It emits radiation in all direction, and it is placed on the center of a hemispherical, perfectly reflecting surface. Okay. Then find the force on the hemisphere due to the light falling on it. So this is power, radius is r. We need to find the force. We can call it is radiation force. What net force will act on this hemispherical surface? And how do we go and solve this question? One way of solving this question is, let's see, this power is W here. But one way of solving this question is, let me calculate the force on a small element of area. And to calculate force, what I need to know what is the energy falling, and for energy I need intensity. So basically what I'll do, since all points on the surface of hemisphere are at same distance r from the power source, everywhere intensity will be same. So let's first calculate what is intensity. This is power. What is the intensity at a distance r from the power source, which we know. Sorry, radius is small r. Okay. So what is intensity? That is pretty simple. Source of power divided by 4 pi r square. We are assuming the rest of it is emitting energy in all direction. Only half the energy emitted is falling onto the hemispherical surface. That's intensity. If I take any small area, what is the pressure on this area? If it is perfectly reflecting, in this case, what happens whichever area we take, important point is radiation is always perpendicular to area. Okay, hence there's intensity will not be into this, no cos theta term, or cos theta term is equal to 1. We calculated last time, the pressure is equal to I by C into cos theta if area vector makes an angle theta with the direction of ray. So pressure is equal to 2I by C. 2 is because of reflection. That's the pressure on a small area. And if I take any area on this hemispherical reflecting surface, every pressure will be same, 2I by C. And what is I? This is I term. I'm not substituting here. This I could have substituted this intent. This is the pressure everywhere. So if this area is a dA, let's take this area. What is this area? This area is a dA. And if I have to draw this as a vector, this would have been is a direction of vector area. And let's see this, we have taken a random area and this angle is theta. This random area with vertical, with reference to vertical, it makes an angle theta. So what is the force on the area? Once we have pressure, we can easily calculate force. And force will be equal to pressure into area. The force on angle D is equal to 2A by C into dA. And which direction the force will act? The force will act, actually the force due to radiation. Radiation force will act like this in that direction. It will tend to push it out. It's just like ball hitting the surface and bouncing back. This is the direction force is acting. But we know in all cases, if I take corresponding area here, we notice what will happen here. The horizontal components, because symmetry will cancel out, only resultant force will be vertical. I hope that part is clear to everyone. So what we do, we calculate for this small force, and then we take its vertical component. So what will the vertical component of force acting on this small area? And you know why I'm taking vertical component? Because then we add up all the vertical component, that will be the resultant force. The horizontal components will cancel out. So this force on the area is dA. So what is vertical component? Force into area. I write 2A by C into dA into cos theta. Now what is this term here? This area A, and is making theta with the vertical. And just now, just before this I discussed, this angle theta is vertical. So this dA cos theta is nothing but projection of this area on the horizontal plane. So this is projection of dA on the horizontal plane. So this, if I project this area on the horizontal surface, this area will be equal to dA cos theta. So I can understand what is the vertical component, but another way of writing the vertical component is equal to pressure and into projection of area on the horizontal surface. In that case, what is resultant vertical component? I add up all those things, I integrate the whole thing. 2I by A, integration nothing but summation. So summation of all projection of dA. So if I take projection of all the area on the hemispherical hemisphere, what is the area we get here? What is the summation of all projection of dA, which is nothing but area of a circle. So resultant vertical component, projection of this equal to pi r square. And then I can substitute I term, this is 2 by C. I term is power divided by 4 pi r square into pi r square. And we notice here, the resultant force is independent of the radius. Whatever radius of hemisphere we take, the reason is also simple. If the radius is smaller, if hemisphere radius is smaller, what will happen? Intensity will be greater and pressure will be greater, but pressure will act on a smaller area. So force is product of pressure into area. So as the distance increases, area is increasing, pressure is decreasing. Pressure is decreasing as 1 by r square. Area is increasing as proportion to r square. Product of this will become independent of r. So it will be this is the term. That's one way of solving. There's another way to solve this question. Another way to solve this question also is, okay, what we can do here. In this case, we can take an elemental area rather than taking a small elemental area. I can take the elemental area as a horizontal ring. And what is the horizontal ring? Horizontal ring is, how do we define two circles? It's an area bound between two rings. What is the ring? One is making an angle theta and other is theta plus d theta. So the ring, everywhere the ring subtends a small angle d theta at the center. So in this case, you can take this ring here, because this ring will make an equal angle with the vertical at all points. And when we take the ring, because of symmetry, I know horizontal component will cancel out. So we can solve through integration this method also. But this is slightly lengthier, and we had done this kind of thing before. So you try and understand this part. This is much easier way. I hope some of you followed. Bhagishri, have you followed this?
Yes, yes.
Okay, so and what, see Bhagishri, what would happen? Suppose I say it is not reflecting. If I say this is perfectly absorbing surface, then what will my answer? It is perfectly absorbing surface.
Need to remove the 2 from the formula.
Remember the two term. So we can solve such question pretty easily. Okay. Okay. I will do some simple question, and you know this particular question I found in some of the book given in this chapter, but actually this question is not necessarily from this chapter. But anyway, let's try and think how to find an answer for this question. All of you just quickly read the question, think, and then we'll solve. From which topic this question belongs to? So all protons are moving at a constant velocity. So it is just, you have to understand this question, just visualize. It's a moving the velocity, cross-section area is 5. So there's a, you can just imagine cross-section is 5 means it's like a, take a kind of cylindrical tube. And cylindrical tube has an area A, which is given as 0.5 mm. And within the tube, there are a number of protons. If protons are having, all protons will have charge plus E. If all protons are moving the velocity, but some velocity V, it will be equivalent to a current. So can we relate this term? And this proton also will have N is number of protons per unit volume. So can we relate this term n, charge of a proton, area of cross section, velocity of the proton with current? How do we relate current to motion of a charged particle? Anyone recalls? So motion of charged particles, so see, just it makes sense if I take a cross section. See, all these protons will cross, and moment protons are crossing, the net charge is crossing, there's a current through that area A. What is the current and how do we calculate this?
NEAVD, sir.
NEAVD. So current is equal to NEAVD. So that's a current. And what is a VD here? Drift velocity. So what are the things given? Knowing the velocity, this V is given, A is given. And what is this term N and E mean? N is the number of charged particles per unit volume. If I multiply by charge, it becomes charge per unit volume. And E is nothing but charge density. N is the number density, and E is the charge density. Rest of the terms are given, we can easily find. So this is something, there will be some question based on the charge density concept, and we should be able to apply in different contexts. Next one, similar question. And this question also, you can answer this question without putting pen to paper. It's something like this, a particle of mass m at rest. And it has some kind of nuclear decay. Nuclear decay is like an explosion. So there's an energy released, and because of energy, it breaks into two parts, M1 and M2. And these two parts acquire some, yes, it undergo explosion. This is a velocity V1 and V2. So both the particles will have some momentum. So corresponding to momentum, they will have certain de Broglie wavelength also. The question is, what is the ratio of de Broglie 1, lambda 1 and lambda 2? How would I calculate this one? So Pritam, can you tell me how would I calculate lambda 1, lambda 2? We are not interested in calculating lambda 1 and lambda 2. We are only interested in the ratio here. How would you calculate ratio? Pritam? Can you think of, and I have given a hint. You don't have to do any calculation. Just look at the question and answer. Pritam?
Yes, sir.
So can you answer this question? What is the ratio of de Broglie wavelength? No calculation, that's a hint.
Yes, sir. Like, we know M is inversely proportional to square of lambda. So.
Yeah, even that much also you don't have to go, but much simpler than that. Anything else comes to your mind? Anybody else? Okay. Abhirup?
So the momentum will be equal and opposite.
Momentums are equal. This is given at rest. So this question is momentums are equal and opposite. If momentums are equal and opposite, when you calculate de Broglie wavelength, it depends only on magnitude of momentum. So whatever momentum, if this has a momentum of P1, this also will have momentum of P1. Both momentums are equal, and this property also I think you have done a number of times. Whenever explosion takes place, how the kinetic energy is shared in inverse proportion of mass, velocity is inverse proportion of mass, and those things we should remember. Momentums are equal. If momentums are equal, de Broglie wavelengths also will be equal. So pretty simple, ratio is 1. Pritam, have you followed this?
Yes, sir.
You should not have missed this point, is it not? Momentums are equal and opposite. Okay, they are inversely proportional to momentum, and momentums are equal and opposite, and de Broglie wavelengths also are equal. Next question. And all this question, I think I just keep solving along. All of you keep solving on your own if you have not done. Some of you might have done similar questions on your own during the weekend. Even if you have not done, you can do it now. A photon electron has equal energy. Okay, important point is when we calculate energy, there are two different formulas of energy we have. What are two formulas of energy here? One case we use something like this, and other case we use energy also. What is energy? Energy is equal to Hc by lambda. There are two formulas. This we should only use for matter, and this we should only use for photon. So that's the only thing we have to keep in mind. One of them is photon. I'll calculate this term for, I'll use this expression, and this should not be any doubt at all. So that's the expression. So let's look at this. We have to calculate lambda here. So energy, electron, energy is related to lambda. Since we have to express in lambda, how is energy related to lambda in case of a matter? It is related as H by P, which is 2m by E. E is the energy of electron, and this m term is coming here. But if I write a wavelength for photon, I will not use this m expression there. There's a different expression. For photon, energy is related to wavelength as what is the wavelength? Wavelength is equal to hc by E. So these are two expressions, and now they are pretty simple. So what is the ratio of lambda p by lambda E in terms of energy? Now it's simple. Just take the ratio of second equation by first equation. You get this in terms of E. The important point is whenever we come across which term we use lambda and energy are related in this fashion for matter, and this is how they are related for photon or a wave. Rest all is simple. Take the ratio, get your answer. Shravani, is this clear?
Yes, sir.
You will not make the mistake in the exam on these two.
Yes, sir.
Okay. Let's take the next question. A slightly lengthier question, and I'll give a couple of minutes. Let's see how many of you get an answer within a couple of minutes. 2 minutes are more than enough for this question. So you have plate A, some distance 4.25 electron volt strikes, and there's some kinetic energy TA. And this kinetic energy there, it will have lambda A also. So whether TA is given, lambda given, both the things are one are related to other. There's another B, again this wave falls, and again this emission of photoelectron. This has kinetic energy, maximum kinetic energy TB. So this is phi 1, this is phi 2. Okay, so anybody has an answer? If not, okay, let's quickly go through. I think not to spend too much time. All of you can practice afterwards also. See, basically, I find two equations are given here. What are two equations given? One equation is given between T and TB, and second equation is given between lambda A and lambda B. But even lambda A and lambda B also can be converted in form of equation between TA and TB. So if lambda is related to kinetic energy of photoelectron, I have two equations between Tn and TB, and once you have two equations, I have get value of T and TB, and then you can get remaining terms also. So key point here in this question was only to convert in terms of T. And how is lambda related to kinetic energy? We know that lambda is related to TB equation. As for lambda, this relationship, if this is given, so this is the relationship we can use. So what does this relationship tell you? Okay, so lambda B will be equal to h by 2m TB is equal to 2 lambda A. I substitute the value of lambda A also for 2 electron. So I get from here, I get a relationship T is equal to 4 TB. So this indirectly, this was another equation, and once I have T is equal to 4 TB, I have another equation here also. I can easily find the value of TA and TB, and once you find value of TA and TB, I think TA comes to 2 electron volts, TB comes equal to 0.5 electron volts. So when TA is equal to TA comes to 2 electron volt, you can easily find rest of the answer also, work function. If TA is equal to 2 electron volt, work function is this one is 2.25, and so on and so forth. The only key point was this, and all these questions I am just giving a kind of hint. I'd expect all of you to solve on your own. This question also, rest of you try and solve on your own, and you can do that. Next question. This is again a question which you can solve without putting pen to paper. The simple question. Source of light. What is changing in this case? So you have to visualize a point source is kept at a distance of 0.2 meter. So initially, there's a photoelectric material. Source is kept at a distance of 0.2 meter. And then we have cutoff voltage and saturation current. So it has some saturation current, it has some cutoff voltage. Then what has happened? Then same source. What does same source imply? Same source imply means frequency or energy of photon is not changed. Same source is placed 0.6 meter away and same material. So phi is not changing, energy of the photons are not changing. It is kept at distance of 0.6 meter. So what will happen if I just change the distance? So this question basically says we have changed only one experimental condition, we have changed the distance. If we change the distance, how would the stopping potential change and how would saturation current change? Okay, so when two things here, what does stopping potential depends on? Stopping potential does not depend on distance, it only depends on source. It only depends on energy of the photon of source. So if I change the distance also, as long as source frequency remaining same, source remaining same, stopping potential will not change. So this is pretty simple. The stopping potential will not change. But when I make the distance 3 times, it is something similar. Can you visualize? If you keep your eye, if you keep a light source at a distance of 0.2 meter, the light appears very bright because more number of photons are, whatever numbers of photons are passing through eye in 1 second. If you make the distance 3 times, number of photons passing through your eye in 1 second will become 1/9. This 1 by r square. The distance becomes 3 times. Number of photons striking the same area will become 1/9. If number of photons striking becomes 1/9, number of photoelectrons emitted also will become 1/9, and saturation current also will become 1/9. So saturation current depends on number of rate at which photons are striking the surface, and stopping potential depends on energy of each photon. So that way, so it will become 1/9. So a pretty simple answer. By changing the distance of the source, intensity becomes 1/9, and saturation current becomes 1/9, but potential remains unchanged. Yes, Akshay?
I got it, sir.
You got
B
it?
is the answer.
Okay,
Yes.
B is the answer. Next question. Shreya, have you read the question?
So 1 minute.
This question also, I think, fairly straightforward question. We can form two equations. What are two equations? One, we can form equation related to wavelength of lambda. And when we reduce the wavelength by 3/4, actually what is happening, when I reduce the wavelength by 3/4, when energy will change by 4/3. Energy will increase, inversely proportional. So if this was E, it is equivalent to saying it will become 4/3. So when energy of photon is increasing, that speed of kinetic energy of maximum kinetic energy will increase, and speed of electron also will increase. When we are solving, I can solve two equations. I can write two equations. Work function will remain same. So to extent there is increase in energy of the photon, there is a corresponding increase in the kinetic energy. So I'll use this equation. E is equal to phi is equal to 1 by 2m square. So similarly, what is V? V square? V square is proportional to E minus phi. Energy of the photon minus the work function. And V dash, in case of V dash, the second case, when the wavelength becomes 3/4, actually I can say energy is 4/3. I could have written that expression also minus 5. So that's the expression. And what we need to find? We need to find the ratio. Whenever, since this question involves ratio, I use the proportion. Whenever ratios are involved, I like proportions better. It solves a little faster. So if these are two equations, since the ratio is involved, I'll take V dash by V square. So what is V dash square by V square? This term divided by this term, the constant proportion being same. So, but I need to convert this term into some kind of fraction. So how do we convert into some kind of fraction? That this is 4 by 3e. So if this term also is 4 by 3e, it becomes some kind of some fraction. So what you do is split this minus 5 into two parts, minus 4 by 3 pi, 5 plus 5 by 3. So this whole term becomes equal to 4 by 3 plus something. So I hope all of you understood this. If you have to solve, it becomes equal to 4 by 3. So basically what we understood, this whole expression will be greater than 4 by 3. Once I have this greater than 4 by 3, my answer is pretty simple. Sorry. So what does it imply? V dash will be greater than root of 4 by 3 V. I was all clear? Shreya, is this clear?
Yes, sir.
Now, why we have done this?
In order to get a simple fraction.
So that's what you need to find. Is it greater or lesser? This is a standard technique we'll use for whenever greater and lesser are there. And once you follow one case, we should be able to apply whenever we have a similar scenario. They're also fairly simple question. They're also forming equation. All of you read through and think how do you form equation. Vikram,
Yes, sir.
have you been following all the questions?
Yes, sir.
No problem. Okay. And any problem whenever I say this is a basic question, that's why I'm going a little faster. Actually, no need to do this question. If anybody has any issue, please let me know in between. So these are also Philly's question. There are two questions here. But again, we'll form two equations and eliminate something. That's the way. But the moment I see such question, okay, this involves two different equations. What are two equations? First way, frequency is mu1. H mu1 is equal to H mu naught. Because here we have threshold frequency. So what he had done in this case, since we have written the threshold work function in terms of threshold frequency, because the question is relating to threshold frequency. That's the only thing we have done. So this is equal to K1. Then we have second equation. And what we need to find, I need to find the value of mu naught. And which term I have to eliminate here? Which term I have to eliminate? I notice H term is not there. Eliminate H based on the ratio. Then the threshold frequency. So kinetic energy, and we can eliminate H, we can get our answer. So these are also K values given, H value gets cancelled out. K terms we write, we can easily get an answer. Work function of lithium and copper are this and this. Which of the following material be useful for photoelectric cell working with visible light? Visible light is basically what? Visible light, what is it in terms of energy? Visible light is something in what range? Roughly little less than 2 to something little greater than 3. And what is that? Roughly we can say 1.8 to 3.2 electron volts. That's a visible light. And so if I use something like copper, copper has work function of 4. If I use visible light with copper, it will not show any photoelectric effect. To show photoelectric effect, the work function of the material should be lower than energy of light which is used. So which one is which will be useful? Of course, only lithium will be useful. Okay. Ratio of de Broglie wavelength of molecules of hydrogen and helium, which are at temperature of 27 and 127 degrees centigrade. This is slightly multi-concept question. Because this is something de Broglie wavelength, we need to know momentum. And to know the momentum, okay, so but temperatures are given. How do we arrive at momentum from temperature? Which principle do we need to use here? Which principle do we need to use here? How is the velocity related to temperature, or is the momentum related to temperature in any manner? Does anyone recall? How is momentum related to Advait?
Yes, sir.
Is momentum or velocity related to temperature? Any other principle you recall? Any relationship between velocity and temperature of a gas molecule? Don't remember? Okay, you don't recall
Sort
that
of,
part?
sir.
Huh?
I remember something related to it, but I don't know what
Not
exactly
okay.
it was.
Ahlad, do you remember that part?
Graham's law, right?
Hmm?
Graham's law, right?
Hmm. Translation motion. So basically, this is we have done in kinetic theory of gases. What is kinetic theory gases say? What is kinetic energy of any molecule? Translation kinetic energy is equal to 3 by 2 kb into T. So what is it say? The kinetic energy is proportional to temperature. Thus the kinetic theory of gases. So temperature is an indication of kinetic energy, and since in case of gases there's no potential energy, is indication of internal energy. That's the minimum what we need to remember as well. That's the kinetic theory of gases. Kinetic theory of gases say that temperature is proportional to kinetic energy. So temperature becomes double, it means kinetic energy of gas molecules is becoming double on an average. And we also use a formula into VRMS. What was VRMS equal to? So that is what. So that is something we need to remember. And kinetic energy of gas and kinetic energy of 1 mole of gas. Kinetic energy of 1 mole of gas is 3 by 2 RT. And this is only in case of translation. And in case of when we take all forms of kinetic energy, including rotational form, we write kinetic energy is equal to F by 2 RT per mole. And this is what a gist of kinetic theory of gases, which all of is such simple formula and not many formula you need to remember. This formula also expect more of you to remember. So this is based on what is given. Yes, Vignesh?
So here we take only the translational kinetic energy, right,
Yes,
sir?
we take only translation. Momentum, since we are talking about momentum, and you notice here, even if it doesn't matter, we are taking proportion. See, whenever ratios are involved, it doesn't matter what is the FLU we use. But ideally, what we have to take, if at all we have to take, we have to take only translation. Are you clear why you are taking translation?
Yes, sir, because momentum. Sir,
Momentum.
but we have to take all of them, it will change, right, sir? Because one is monatomic
Nice.
and the other is diatomic.
But monatomic, diatomic, okay. No, so that's it. Let's come to that part also. Monatomic, diatomic, where would it figure? Okay. And if you want to understand a little better, again, go back to kinetic theory of gases, try and understand what happens there. And here, when we talk about de Broglie wavelength, we talk about linear momentum. Okay, and linear momentum related to translation kinetic energy.
Yes, sir.
So first of all, you have to take only translation because we talk about linear momentum here. And since second point is, this involves ratio. Whenever ratio involved, the proportion is good enough. So all I need to know, the kinetic energy is proportional to temperature. Then since I need to calculate de Broglie wavelength, see my understanding is de Broglie wavelength, I know how it is related to mass and kinetic energy. But what is happening, since temperature is given, in place of A, I can substitute D. So what is the ratio of these two terms? Let's see what diatomic, monatomic, where it will come. If I have to calculate wavelength of hydrogen molecule divided by de Broglie wavelength of helium, so this term will go here and this term will go here. Okay. So here anywhere, what, since it is diatomic, hence mass will be equal to twice the mass of a proton. And this is equal to 4. Had it been monatomic hydrogen gas, this term also mass would have changed. Are you getting what I'm saying now?
Yes, sir.
That's all need to change. That's all is temperature. As simple as that. So that's the ratio. So this is something, only thing what has been done, only thing we have to make use of, K is proportional to T. So straight away, since we are taking ratio directly in place of K, we can substitute and get an answer. Dhanshri, have you understood this?
Yes, sir.
Okay. Next one. So again, it is a ratio. What we need to find? We have to find the ratio of lambda of alpha and proton. So both are particles. And both have same radius. So what is radius of a charged particle moving under the influence of magnetic field perpendicular to it? That we should know. So what is that part here? Radiuses are equal. So thus we'll use the condition radiuses are equal. We substitute radiuses. What is radius equal to? Momentum. Radius is what? Radius of charged particle moving is equal to mv by qb. So which is radius is equal to momentum by qb. And we are interested in momentum only to find de Broglie wavelength. So for alpha particle, Pa divided by charge of alpha particle into B. And for second is a proton. So momentum of the proton divided by charge of a proton, which is E into B. This is what is given. And what we need to find? We need to find the ratio of lambda. And ratio of lambda is inversely proportional to momentum. So this is Pa by PL. So very simple question. Kevin,
Yes, sir.
are you following so far?
Yes, sir.
All these questions you can solve.
Yes, sir.
So this is a question, this is human eye, the way in case of sound also, we need certain minimum intensity for sound to be audible. And you know, in case of sound, if I recall correctly, that's what we call decibel level. I think sound, it is something 10 to power minus 12 watts per meter square. If sound intensity is less than that, our energy per unit area, per unit time of the sound wave created is less than this, our normal human being cannot hear. Something the light also, if we have a power source, if you have a tiny little, so like LED bulb is there. You know, and as we keep increasing the distance of LED bulb from our eye, it will keep looking more and more feeble. And if we take very far at some point of time, because as we are taking it away, intensity will keep decreasing. As intensity keeps decreasing, the moment the intensity drops, this is what it says, moment intensity drops below this level, we won't be able to see that light, which happens. That's why the any light which kept at large distance, we are not able to see. Because intensity drops, or other way of saying, if LED bulb is emitting photons, number of photons entering our eye per unit time will drop to a very small number. This is something like this. That's what the question is. So minimum intensity detected by human eye is so 10 to power minus 10. This is given information. You don't have to memorize this number anyway. What is the number of photon? So this wavelength is given. Wavelength is given means energy of each photon is given. Entering the eye with pupil area is also given. What is the number of photon must be entering eye for us to see an object? So this question also simple. We have to use intensity, energy of photon, area, and n. What is the equation we form? What is intensity, energy per second? See, basically when it energy per second, energy entering our eye per second will be equal to number of electron entering our eye per second into energy of each photon. And thus energy which will enter our eye, energy is equal to number of photons entering our eye per second and energy of each photon. And what is the energy which will enter our eye? What is the energy required? Intensity into area is equal to n into energy of each photon. This is a simple equation we form. Is this clear to everyone? Intensity and intensity multiplied by area gives you the energy which must enter the eye per second for us to detect any light, which is within the visible spectrum. We form this equation, we get the value of n. And in this case, if since intensity is given in SI unit, it's better to use energy of photon also in SI unit, SC by lambda. You'll all substitute in SI unit. Okay, a couple of more questions, something like this. Let's see, understand this part also. Just imagine a conducting sphere is placed in a vacuum. So there's a sphere, conducting sphere, and this has some radioactive property. And you know, any sphere, it will have free electrons, and typically, initially we expect, if nothing else is mentioned, it's a neutral conductor. And if EM radiation starts falling onto the surface, what is the monochromatic radiation? Energy equal to 4 electrons. So this EM radiation, each photon, since it is monochromatic, all photons will carry same energy equal to 4 electron volt, and it has a work function of 2 electron volts. So naturally what will happen, since this energy is greater than work function, it will lead to emission of electron. It will lead to photoelectric effect. And so as the photoelectric effect continues to take place, the sphere will keep losing electrons. Hence it will acquire positive charge. It makes sense. So it moves if it loses an e electron, it will acquire a charge equal to, the Q will become equal to, so charge on the sphere will equal the number of electrons, photoelectrons left into E. And as the charge is with time, as n keeps increasing, the charge of a conducting sphere also will keep on increasing. So as it again, if charge keeps increasing, and of course the net charge will lie on the surface, it will acquire certain potential. So effectively, so in addition to normal pulling force, there's additional pulling force because of the charge on the sphere. So this also, if it acquires a potential V, it is equivalent to increasing the work function by amount equal to V. So if initial work function was 2, at some stage, if it acquires, potential of the conductor V is equal to KQ by R. If this becomes equal to 2 volts, what will happen? Effective work function
become 4 volts.
become 4 volts. And beyond that, what will happen? Photoelectric effect comes to a stop. It will not continue. So just understand the sequence. As it keeps falling, it will liberate photoelectrons. As photoelectrons keep leaving, it will acquire positive charge. So basically, if I am not writing all the steps here, it will acquire positive charge. And as it continues, positive charge will keep increasing and potential also keep increasing. Effect of the potential is to increase the work function by the same value. So moment, basically what we are saying there, so if I have to summarize right in terms of one single statement. So number of photoelectrons we lose, still photoelectric comes to a stop. What is the condition for number of photoelectrons to do? Yes, Vignesh?
Sir, I didn't understand how the potential developed will increase the work function.
Work function, okay. No, this is okay. See, another way to understand you this also. Suppose I have a conducting plate here. Okay. If I have a conducting plate, and let's say this has a work function of 2 electron volts, the work function of 2 electron volts. Radiation which is falling is 4 electron volts, right? So if this one plate, and just like your vacuum tube, so suppose I create I create a potential equal to, if I make this potential equal to 2 volts and this has 0 volts, what will happen? Is it not acting as stopping potential now?
Yes.
Is it same diagram as before?
Yes.
And what is it is equivalent to? I am applying a stopping potential of 2 volts. So it will not reach here. Are you following this point here?
Yes, sir.
Now, when we come this case also, this is a conductor. This has a potential V, and this is space here. Space is at potential 0 space. Is this scenario not similar to this scenario?
Yes, it's similar.
It's similar. Now, so basically, it will tend to pull it back. So very simple terms, what we understand here. If we want to summarize the whole thing, what is the effective work function? Effective work function is the work function of the metal plus the voltage developed. And what is the voltage developed? Voltage developed is KQ by R. And what is KQ? Q is equal to E times the number of electrons which are photoelectrons which are left. That's the condition. Okay. So this is something additional thing we can, as a rest of you also followed this point. Tejas?
Yes, sir.
Tejas, are you clear?
Yes, sir. Yes, I'm clear, sir.
Okay.
Got it.
It can sometime it will come number of electrons to do till the photoelectric comes to stop. So I can easily find the value of n here from this. Okay. I can do one more question. This is a very interesting question, and perhaps it makes you understand something else also. Just read the question. Two equal masses are traveling on x and y axis have a d Broglie bevel lambda 1 and lambda 2. Let me visualize also what is happening here. So the two axes and two equal masses. This mass m is also moving, and this is moving with velocity v1, and this mass is moving with velocity v2. Two equal masses, and they move along x and y axis. And moment they have momentum, it has a wavelength of d Broglie wave lambda 1, and this is lambda 2. Of course, how much lambda will be equal to h by p? It will be, first one is lambda is equal to h is equal to mv1, and lambda 2 is equal to h by mv2. So that's what is given. Two equal masses are traveling along x and y axis. They have d Broglie wavelength equal to lambda 1 and lambda 2. They undergo an inelastic collision. So what happens? Yes, they pretend that they come and collide here. And after they collide, yes, they will move in a, it will start moving as a one single mass. What would be the d Broglie wavelength of the combined mass after collision?
Central mass velocity.
So basically what you have to do, every time when we think of any such thing, d Broglie wavelength, I think of momentum. So all I need to do here, see here the momentum was mv1, this momentum was mv2. I need to look at, okay, this, what is the momentum, resultant momentum here? If I know the momentum here, I can write it. How would I find the resultant momentum?
Velocity of central mass.
How would I find conservation of momentum? This momentum here, combined particle, this momentum will be sum of the initial momentum. So basically, whenever collision takes place, so since I have to find d Broglie wavelength, what I think now, to find d Broglie wavelength here, I need to find resultant momentum. How do I resultant for them? Conservation of momentum. How do I write conservation of momentum? So this momentum has to be equal to sum of these two. The resultant moment, initial momentum of P1 we may do. What is the momentum after collision? So let me write this expression. So if initial momentums are P1 and P2, what is the momentum after collision? So if since momentum is a vector quantity, let me write what is the resultant momentum. Resultant momentum will be equal to vector sum of initial momentums. And what are the initial momentums? I can write as P1 into I cap plus P2 into J cap. They are mutually perpendicular. But we are only interested in magnitude. What is magnitude of resultant momentum? Because in wavelength, we are only interested in what combined magnitude. What will the resultant momentum be equal to in terms of magnitude? It will be equal to P1 square plus P2 square. Can I write now P1 and P2 can be written in terms of lambda 1 and lambda 2? The resultant momentum, H by final momentum, resulted lambda, and this will be equal to root of h by
Lambda 1 square plus
lambda 1 square plus h by lambda 2 square. This is equation. So what is my one resulted lambda square is equal to 1 by lambda square plus 1 by lambda 2 square. And this is and you can have some variations of the similar question. So let me repeat. See, this is this understood. Gayatri, have you followed? You are clear? Okay. Gayatri, tell me if I had mentioned masses, I have mentioned two masses are equal. Had I mentioned masses are not equal, would it make any difference? Will the answer be different if masses were not equal? It doesn't make a difference. We are just taking the vector sum of momentum. Okay, here the mass is not figured anywhere. Only thing what would happen if masses were equal and they were traveling with equal velocity, then after collision they'll move an angle of 45 degrees with each of the two axes. Otherwise, those are irrelevant here. Okay. Okay. Now coming to one part, some of you are asking this question. Let's see. See, suppose you have a beam of light. What is beam of light? Like a laser ray. So there's a plus try and understand what is beam of light mean. So there's a beam of light. Let's take it as a circular cross section. Even laser ray and all also something like beam of light. So let's say this beam of light has an intensity of I. And to calculate intensity, so and is cross section is circular of radius r. Okay. Who is this? Nice song.
Sorry, sir.
It doesn't matter. It's okay. But okay. How is this related to this question? Sitare?
No, sir, it's not.
Not related. Okay. I was just trying to see the connection. Maybe I thought you have some connection with this. Okay.
So it was playing in the background. That's it.
Okay, good. So let's see. So this is a beam of light. Now, since you started singing, now you have to answer some question. Be ready now. And this is a beam of light. So what do you do? Suppose this is a laser ray. All you can visualize laser ray. We can see in the sky and all also. Suppose I keep a plate perpendicular to direction of this beam of light. So wherever this light falls, that part of the plate will lit up. The rest of the part will remain dark. Jaideep, is this understood?
Yes, sir.
So you have kept a plate. What is the area of the plate which will get lit up? Or what is the area on which this beam of ray will fall upon?
So the component of the area which is perpendicular to that.
Okay, you are still singing mode only. Okay, let me ask somebody else then. Okay, so let me ask someone else. What is the Bhagishri? Can you tell me what have you understood, Bhagishri? What is the information given and what I'm asking now? See, Bhagishri.
Yes, sir.
Bhagishri,
Yes, sir. I'm there.
are you also singing something? No.
No, sir.
Not singing. Okay, good. So there's a beam of light, and it's a parallel beam of light, and its intensity I is given, and its beam of light is circular in cross section. Radius is r. Have you understood how the plate is placed here? Can you tell me what did I say? How is the plate placed?
It's perpendicular to the direction of
The surface of plate is perpendicular to direction of travel of a beam of light. You understand here, if I place the plate here, only certain part of the plate will get lit up. Rest of will remain dark. What is the area of plate which will get lit up?
It's pi r square, sir.
It will be pi r square. Then this part it will fall on. So basically what we are saying here, in that case, photon will fall onto the area which is equal to pi r square. That was simple. Now, if the plate is kept like this, it will fall into pi r square. So intensity also, so whatever energy, so energy, okay, that's a pi r square. So in this plate. Now, suppose what we do now, if I change the orientation of the plate by angle theta. Now the plate is making an angle theta. So if I draw, so previous case, if I had drawn a area vector and light vector, direction is the wave is traveling. Two vector. What is C cap here? C cap indicates direction of light ray. A cap indicates area vector. Earlier the angle was 180 or 0, which makes no difference. If I rotate now, the angle between area vector and C is theta. Plate is making plate is or not. Plate is inclined at angle of theta from. What is the area which will lit up now? Now area vector and C vector. Area is at angle theta. Earlier the angle was 0. Angle 0 implies surface is perpendicular. If angle is not 0, it is not perpendicular. Are you clear? One A and C, where the C is direction the light is traveling. 0 angle means surface is perpendicular. Now this surface is not perpendicular. What is the area which will be lit up now? What is the area on which the light will fall?
As per secant theta.
Very good. It will be equal to area will become A by cos theta. Because there's something, this area is projection and this is equal to A. So A cos, this A dash cos theta is equal to A. And so basically it will be equal to A by A secant theta. Are you clear? It will be A secant theta. That's area. Now we come to other part here. So this is something the light falls. So I have kept up this something. So is this understood? So it will fall onto this area. This part first we have to understand. It will fall on area. I can say A by secant theta, A by cos theta. So, but now we move to the next part of this question. I remove this part here. Now come to this question here. So again, let's say the light is of cross section area A. So again, same thing. Light is falling, and what is given here? This angle is theta. The same beam of light. Intensity is I, and area across it, this is R. Okay. Now, if I ask the question, find energy incident on the plate. This is the plate here. And let's say A is equal to pi r square. So pi r square also defined as A. What is energy incident on the plate? Now basically I into A, no problem. Energy incident on the place I into delta T. Or if I say what is the power incident on the plate, it will be same. Whatever power is same thing, I into area. Power incident on the plate. I think this is I into A. Now if I ask now basically, and if this light gets reflected, light is getting reflected. If surface is perfectly reflecting, can we calculate force on the plate? What is the force which will act on the plate? How would you calculate beam of calculating? What is the force on the plate? How would you calculate force now? So basically what we know, how do you calculate force? So we know what is the power which is incident. I can, whole thing, if you have to simplify, I can think of something like this. I can think of like this, what is incident? Some momentum is incident here. And this momentum is again, this something is bounding. After reflection, this is incident momentum, this is reflected momentum. And if in reflection is perfect, both will be at same angle theta, and this momentum will be equal. So if this is how momentums are incident and bouncing back, it is equal to ball striking the surface and bouncing back. What will be the change in momentum in this case? You can easily tell both incident momentum and reflected momentum are equal. It will be equal to, what will change in momentum?
2p cos theta.
2p cos theta. It will be 2p cos theta. Can we write momentum in terms of energy? Is momentum and energy related? Are momentum and energy related? What is the relation between momentum? What will this initial momentum if intensity is I and area is A? How is momentum related to energy? So is this understood? So basically, if I keep the plate here, the change in momentum will be equal to this term here. Change in momentum is equal to 2p cos theta. How is P related to energy? Momentum. How is momentum related to energy?
E by C.
Huh? E by C. Energy by C. What is the energy here? Energy will be equal to what if I write Pi? What is the incident energy? In that case, Pi will be incident energy. We just mentioned I into A into delta T by C. So change in momentum will be equal to 2 into I into A into delta T by C. So what is the force acting on this? So force acting will be equal to, sorry, I have didn't write cos theta. What is the force acting? Force acting will be equal to 2IA by C into cos theta.
Sir?
But if I continue further, what is the pressure acting on the surface? Pressure on the surface. What is the pressure on the surface? How do you calculate pressure on the surface? Can anyone think of a method of calculation pressure on the surface? This force is acting, but this force, if you have to calculate pressure, this force is acting on what area? Area of cross section of the beam is A, but what is the area on which it is falling? Just now, some time back we discussed, but area is equal to A by cos theta. So when you calculate pressure, I have to get force by area on which beam is incident. So how much that is equal to? That is equal to force divided by area by cos theta. It will become equal to 2IA by C into A into cos square theta. That's the pressure. It will become 2I by C cos square theta.
Sir?
Yes?
So the power incident on the surface doesn't depend on the angle, right, sir?
Of course not. Does it not make sense?
Yes, sir.
See, if there's suppose reflection is not taking place, whatever power is coming, where it is coming, it's coming. But what is happening if I keep the plate like this? The power is incident on a smaller area. If I keep like this, it gets distributed over a wider area. See that each part couple of times just go through. See that each steps are clear. Why I didn't do this question? Because this is something it gets some of you get more confused. Has someone followed this? Honestly, tell me how many have followed what I said just now. How many have followed and how many can redo this something after on your own? Only 2 people followed? 3. Oh, Tejas also. I see. Okay, so good. I got some number of people. This something gets a little tricky. I think some people there are 2-3 things all put together. All those few things are not very difficult, but it requires bringing some 3-4 things together. What is energy? How is power? How do we calculate pressure? And that becomes equal to so very simple terms. What we understood now, if there's a beam of light. Like sun rays are coming. In sun rays, if intensity of sun rays is I, if I keep any shape of plate, if it is a reflecting plate, if I keep it perpendicular to the surface, pressure is equal to 2I by C. But if I rotate by angle theta, the pressure becomes cos square theta times. That's the only point we understood. If I rotate this plate by an angle theta, the pressure becomes 2I by C into cos square theta. You understand reason also why it becomes so. There are 2 reasons for cos theta is coming because of 2 things. One is cos theta is coming because intensity itself is getting reduced. And second, cos theta is coming only the perpendicular component of force is creating pressure. So there are twice we are taking the component. That's why cos square theta. So Vignesh, is that what your question was beginning of the class?
Yes, sir.
Are you clear now?
Yes, sir. Sir, but I didn't understand the point. You just said the intensity is getting reduced.
Intensity, okay. I think I'm okay. I'll repeat that point. Good, you raised this question. Okay, so the rest of you, those who want to leave now, I think class time is over. You don't want to confuse your mind with this thing, you can skip. Okay, when I talk about intensity, let's first talk about, see, the sun rays are coming here. And okay, let me start with some very basic things first. So that we are more clear. And let's say there's a point source like sun. It could be like sun also. And from point source, if it is light is spreading all direction, we understand as we go farther, intensity at A will be different, intensity at B is different. But when we write intensity, I think this is sometimes a little confusing. This may not be the right term. What I can say, the magnitude of pointing vector at A and magnitude of pointing vector at B. How would magnitude of pointing vector is? What is the magnitude of pointing vector? Magnitude of pointing vector is equal to intensity on which surface? Surface which is perpendicular. Okay. That's a perpendicular. So this is something, so many times when we talk about intensity without mentioning the angle at which the area is, we assume that if this area is perpendicular, which may or may not be. Okay, so intensity is, so if it is traveling, the distance also between A and B, intensities are different, and it is different because rays also are divergent. But when we come to a large distance, when we say at large distance, the rays are almost parallel. Does it make sense? Why do we say the rays are almost parallel?
Yes, sir.
This part also very clear. If we continue, if this dimension is much smaller than the distance dimension, the rays at a large distance, when the delta R is much smaller compared to distance from the sun, the spreading of the angle becomes too small, it appears to be parallel. And when rays are parallel in a region, we can assume the pointing vector here and here to be equal. Okay, so that is something that we can take pointing vector intensity to be equal. Now coming to second part. If rays are like this, just now we discussed, if rays are falling like this, If rays are vertical, like sun rays are vertical. If sun rays are vertical, see sun rays, if pointing vector S is constant always. S is constant on any point on the earth. Why is S constant? Vignesh, you only started this question. S is
because
constant.
very far away.
No, it's very far away. S is constant. Only thing what will happen, sun rays form at different angles at different times on the earth's surface. Let's see, when it is falling like this, if I take what is intensity of sun rays falling on this surface. Now the surface is perpendicular. In this case, intensity is equal to S. But what happens when the sun rays are falling at an angle? If I take an area, is this energy falling? So here I have taken some area A, at same area I have taken here. Same area, let's see, I have kept a plate in the afternoon time, just when the sun is vertically above. And this time this area plate is same. Do you think the same energy will fall on this area, this plate also?
The energy will be same, right, sir?
Huh?
Energy falling.
Energy will be same as energy passing through this cross section.
Yes, sir.
But what is this cross section now? See, the energy which is passing through cross section area A is incident on an area which is A by cos theta. Hence, the intensity becomes lesser. And
Yes,
the reason what is said also, and when you have Earth surface like this, here intensity near the equator is greater. Here the intensity is smaller. Though the pointing vector here and here are same. Are you getting this point here?
yes, sir, I understood.
Are you clear now?
So it's like the power divided by the area, right, sir?
So we are saying same energy, but which energy now? This is something, it is lesser energy.
Yes, sir.
So that's, I think, which was creating confusion. Are we all clear now? Abroop, are you
Yes,
clear
sir.
about this?
Yes, sir.
Very clear? Okay.
Sir?
Yes?
Sir, I also have one more doubt in that work function question, sir.
Yes, tell me.
Yes, sir. In that question, sir, like the work function in the beginning, it's just because of the like the attraction between the proton and the electron, right, sir?
Yes.
Now
See,
the new
earlier,
voltage
yes.
will create a similar effect.
Yes, it is creating a similar effect. It is because of one way of simple way of saying it is because of some force which is attractive in nature. And that force of attraction acts when the whole thing is neutral, only electrons are trying to leave. When electrons are trying to leave the surface, it is creating some net charge. Now there's, in addition to the neutrality of the conductor, it has certain positive charge. It creates additional pulling force. And the pulling force we can again, since we are talking about in terms of, see, I think much better is, have you understood the figure? Try and understand the figure again, what I mentioned.
Yes.
Because that is much better. If you try to recall in terms of understand in terms of force and all, it's not that clear. Now, this is something, it creates similar effect as keeping a plate which is at a higher potential here. Repelling force. So here this creates a repelling force. Here within the conductor, we are creating a similar attractive force.
Yes, sir.
Okay then, and anything else?
Sir, plate at lower potential, right, sir? On the other hand, on the other side.
Sorry, plate, that's a negative. No? Plate is at lower potential. It has negative charge. That's why it repels. So that's why when this is positive, if see basically what we are saying now, I'll put it in here. So 0 and -2 is equal to, this is your photographic plate, photoelectric plate, and this is other charge. This 0 and -2 is equal to this is plus 2 and 0. Yeah.
So it will lose energy either way, the electrons.
Yes. Okay, then I'll stop here. So if anybody has any query, you can send me a WhatsApp or something and I'll respond. Okay.